This topic is finding a limit at a point of continuity. So what are we doing now? We've evaluated limits using tables. We've evaluated limits looking at a graph. Now we're going to be evaluating limits algebraically. We've already reviewed the limit rules as well, like the limit of the sum is the sum of the limits and the limit of the difference is the difference of the limits. If we put all those limit rules together and we consider polynomial, rational, and radical functions, what we determine is if we want to find the limit as x approaches a of a function, all we have to do is plug that number into the function and see what we get. If an actual number comes out when you plug in your desired x value, if you get a nice y value like 5, then you would say the limit is 5. So the easiest way to find a limit is always to try direct substitution. Just plug in the dang number into the function. If it works, great, that's the answer. If you get something like 0 over 0, that's called indeterminate form, and there's going to be some other techniques depending if it's a rational function or a radical function that we're going to need to use. But right now we're going to always start with the easiest method, direct substitution, and let's see how that works. So let's go to our examples here. It says finding the limit. The first one says the limit as x approaches -3 of the quantity 3x cubed plus 2x squared minus 9. So again, the first thing we always want to try is direct substitution. We look at the function, and wherever we see an x, we're going to plug in the desired x value. In this case, that's a -3. So I'm rewriting the function, evaluating it at -3. I'm going to go ahead and use my calculator here. Plug it in. 3 times -3 cubed. Make sure you get out of the exponent. Plus 2 times -3 squared. And then we have a minus 9. I hit enter, and I'm getting a value of -72. So by direct substitution, we plugged it in, we got a number. That number is our answer. If you get a number, that's your answer. Let's try the next one. The next one says the limit as x approaches 3. Then we have a rational function. We can try directly plugging it into the rational function. It's 3x plus 6 all over x cubed minus 9. So when we plug it in, it would be 3 times 3 plus 6 divided by 3 cubed minus 9. I'm going to plug this into my calculator as well. Let me clear that out. I'm going to hit the fraction button. 3 times 3 plus 6. And then in the denominator, I'm going to do 3 cubed. Get out of the exponent, minus 9. Hit enter. And my calculator simplifies the fraction for me. I'm getting a value of 5/6. Again, that means that 3 is in the domain of my function. I plugged it in and I got a value out. And using the limit laws, I know that because I got a number, that number is the answer. The third example here is an example of a radical function. So we know it worked with a polynomial, it worked with a rational, a fraction. It's also going to work with a radical or a square root as long as it's defined. So we have the limit as x approaches 2 of the square root of x squared minus 2x plus 9. I'm going to try direct substitution first. That's what I always want to do. I'm going to have the square root of 2 squared minus 2 times 2 plus 9. Make sure your writing's clear. Plug this into my calculator. So I'm going to do second x squared for the square root. 2 squared minus 2 times 2 plus 9. I hit enter. Oop. Typed in something wrong there. I can see that I didn't have a parentheses around that first 2. So I'm going to enter that parentheses in the front. Always make sure you enter it into your calculator properly. And I'm getting a simplified value of 3. Because I got a number, that number is the answer. So how do we evaluate limits algebraically? The easiest way to do it is by direct substitution. Plug in the number and see what you get. As long as you get a nice number and it's a polynomial, rational, or radical function, then that number is the answer. I hope that helped.